93% of organizations now use AI-generated code, yet only 12% apply standard security controls. This is really highlighting the massive gap between AI-driven development and deployment and speed of security and software practices. My name is Paul Nashawaty, and I'm the practice lead and principal analyst at the Cube Research. And I'm joined by Brian Fox, CTO from Sonatype. Brian, how you doing today?
Hi, thanks for having me.
Yeah. Brian, why don't you tell the audience a little bit about yourself and about Sonatype?
Sure. I'm Brian Fox, as you said, co-founder and CTO here at Sonatype. I have a long history in open source. I worked on Apache Maven for a long time, and of late, I'm on the OpenSSF governing board, the Finos Financial Open Source governing board, and several other related things, helping the industry understand how to best manage their open source consumption. Sonatype, among the things we do, we run the Maven Central repository, which is where all the world's open source Java comes from. We have other products, repository managers, software composition analysis, and malware defense that we've kind of built over 2 decades of kind of learning from what it takes to run those critical repositories.
Well, Brian, it's a pleasure to have you on the podcast. It's really relevant to my audience here. We definitely value your insights and input. But, Brian, when we see AI is rapidly, it's really reshaping how software is getting built. But the data reveals growing disconnect between speed and security. We see that 93% of organizations now leverage AI-generated code, as I stated, but yet only 12% are applying consistent security controls. And the industry is accelerating development faster than it can secure it, right? So when we see this, at the same time, nearly half of AI-assisted code, it really introduces potential vulnerabilities, signaling where AI is reducing friction in development, but it's also amplifying risk, right? So the result is the new reality where innovation is no longer constrained by productivity, but how effective can organizations manage and secure AI-driven outputs at scale? So Brian, let's jump right in. I mean, I think that your insights here and what we're talking about with AI safety at machine scale, it really isn't optional. AI accelerates software development and scale of code generation is really outpacing traditional security controls. So how should organizations redesign their development security pipeline to ensure AI-generated code is safe by default or at machine scale?
Yeah. So if we take a step back for a moment, right, one of the things that we've been focused on for a long time is helping organizations better manage that portfolio of open source dependencies, right? So the modern application for 2 decades has been 80 to 90% open source components. And so organizations are all over the map on how good they are at managing it. But if you think back to Log4Shell, think about how many organizations it took months for them to even figure out where they were using it. Our customers had alerts and they knew where their risk was the next morning, right? And they were able to start remediating when other organizations were months behind triaging. So this is the difference between managing that portfolio of dependencies and having literally no idea. And so what we've long been focused on is how do you manage that at scale and across thousands of developers, thousands of applications, these types of things. The main competitor to that, if you will, are organizations who would do it manually or very ad hoc mode. And that can be okay when you have a few developers, but not okay when you get much larger. Now, when you introduce AI and the capabilities and some of the agentic stuff, if you don't have the process in place to actually encode the rules about what open source dependencies are allowed in which context, you have no chance, right? In the old model, you might have a human reviewer or people talking at lunch that say things like, oh, we never use those licenses, or we only deal with these types of vulnerabilities. These kinds of things could be sort of tribal knowledge. Well, in AI, if it's not written down, it's not known. And so those types of processes need to be encoded in a way that AI can react to. The other challenge that organizations will find is that the AI models, the LLMs themselves, of course, there's a cutoff period. They're trained at a point in time, and then they're released, right? And the information that is embedded inside that model, even at the release date, is some period older. It took some time to actually do the statistical analysis to put it into the model. And so what that means is any given model has no information about new versions of dependencies, new vulnerabilities that have happened. They have no way of knowing about malware that exists in new dependencies. And so what we see is that if you're solely reliant on an LLM to make dependency recommendations, or even to do things like do a security analysis of the dependencies in there, it's potentially going to give very wrong and at least outdated information, right? And so we've done a lot of research lately to kind of show how you can ground those models in real-time data and how much of an impact that makes.
So, Brian, let's talk about that. There's a shift from hallucinations to hesitation. It really does introduce this new risk, right? AI models are improving accuracy, but increasing inaction over cautious outputs that could quietly allow for unresolved vulnerabilities to persist. This is, in my mind, are we trading one problem for another? Are we reducing hallucinations by increasing vulnerability debt? How should teams really strike a balance here? Because I like what you were talking about with the human in the loop piece, but there's also we have to get to a point where productivity and operational efficiencies take over here. So what are your thoughts?
Yeah, so what we've seen, we've done the analysis, and I think we could share the actual report because the images, the pictures of the graphs tells the whole story here. But we've looked at all the different frontier models going back at least a year, and we've analyzed them against recommendations of known enterprise bills of materials. We've done the analysis across, I don't know, thousands of real applications to understand what it would have predicted at the time. What we found is across all of the different model vendors over the last year, they've gotten much better at not hallucinating versions and dependencies, right? And that sounds good. But the problem is, if you put that in the context, if you had an actual build tool, say Claude, and the Claude model recommended a version that doesn't exist, as soon as it tries to run the build, it's going to blow up because that thing is not resolvable. So it's fun to kind of laugh at the hallucination. It's like, oh, it can't even get that right. But I would say that that's sort of, transient risk. It's fail fast mode. It doesn't have lingering consequences because, while it wastes a few tokens doing the build, it may realize a mistake and then it'll fix it. What we found is that all the models over the last year have gotten much better at not making up versions. But surprisingly, what we found at the same time is they basically proportionately got to the point where they make no recommendation. And so what the practical implications of that are is if you say, hey, I have this bill of materials, recommend for me some security updates. And in instances where it might have gotten things wrong and then failed fast, now it will come back and say, no, you're good. And when we analyze the impact of that, we found that it significantly decreased the security posture over the previous version. So in a way, they got better at not hallucinating, but it came at a significant trade-off. And I would assert it's actually worse. And the reason for that is because getting the false negative information is actually persistent risk, right? Whereas the first one would fail as soon as it tried to do the build. This other one leaves you with a sense of, I did the analysis, everything is fine, and I'm not going to check it for another month, when in fact you might have significant vulnerabilities or out-of-date information. So I don't even think it's just trading one problem for another. I think it's actually a regression in the actual practical output of the use of the tool.
Yeah. So, but does vulnerability debt, is it becoming the hidden cost of AI adoption? I mean, we see AI tools generating, and modifying code rapidly. Unresolved issues accumulate faster, and teams can remediate these issues, but making technical debt a real security problem. So, what do you see as strategies or metrics that leaders should be adopting for identifying to reduce their vulnerability debt to introduced by AI-driven development? Based on what we were just talking about, it sounds like we're kind of moving forward, but it's also adding different levels of debt. What are your thoughts?
Yeah, so what we see is that if you take real-time information and you inject that into the AI conversation through tools like MCP or response augmented generation, RAG types of things, right? The information now allows the LLM to do what it's really good at, which is reason across these things, provided a set of facts that are recent and relevant for the particular things going on. And we've found that when you do that, it should be unsurprising, but it's worth saying the output is like dramatically better. Taking a tiny model like a nano model and providing it with grounded information for dependency purposes actually performs better than a bare frontier model all by itself, right? Now, we wouldn't suggest using one of those micro models to actually write code, but it kind of highlights the point that it's not about the model, it's about access to the real-time information. Like, think about it. Literally no CISO in the world would say, you know, what would be awesome is if I ran my security team on 6-month-old information, and that's what they were going to react to. But that's the practical implication if you're using AI-based tools and you don't have a data feed that is integrated into that is providing that real-time feed. It's literally
I totally get that, but like grounding AI is really the key to trustworthy outcomes, right? So connecting AI models to real-time data policies and validating source dramatically improves the reliability, traceability, and security outputs, right? We see that, we know that, and that's kind of where I think where you're going with this. But how does grounding AI in enterprise context and trusted data sources fundamentally change the quality and security of generating code? Because that's not necessarily the same thing, right? Because the code is being created. If it's grounded, it's going to provide a better source or better quality. But what happens if it's not? You know, I think that's really where the challenge is here.
Yeah, well, I mean, if you started coding something today and it picked an out-of-date, end-of-life version of Spring, for example, as your framework, I think it's obvious to everybody why that would be a terrible idea. The actual code that gets created might itself not be broken, but you're building it on something that is immediately going to have to be refactored into a modern version, right? If you're pulling in versions of dependencies that have known significant vulnerabilities by default, and nobody's paying attention to it, or worse, you ask it for an assessment of this and it says everything is good when you've got vulnerabilities hiding right in plain sight, that should be obvious why that's bad, right? So what we're talking about here isn't so much about this changes, let's call it the first party code that gets generated. It changes the first party code in how it's choosing to use the dependencies. And so making bad dependency decisions right up front only gets perpetuated as you start to build more and more code on top of it, right? So that's how this interplays, right? We're not talking about it's going to change exactly the version of the code. Like, the models empirically are getting better at producing better code, but because they don't have access to that real-time information, the foundations that they're choosing to build those on are at best out of date and at worst potentially compromised.
Yeah. So I mean, are you saying the future of development is really about being AI native, right? The security has to evolve with it, right? And AI-driven development will shift teams from writing code to orchestrating systems, requiring new roles, governance models, and security frameworks. So I guess what I'm thinking here is, what does a full like AI-driven development lifecycle look like in the next 3 to 5 years? And how must security kind of evolve to keep pace with that? Because that's a big challenge here. Well,
yeah, I mean, I think we're seeing it already, right? Forward-leaning organizations are writing significantly more code, whether they're doing it fully headless, agentic, or if they're just using developers driving the machines. The result is the same. If it's making terrible dependency decisions and building on top of those, it's not going to lead to a better outcome. And it's obvious, especially with a lot of the buzz around things like the Mythos and the Glasswing kind of stuff, and the new models that are coming out and how good they are at creating exploits. It's clear that organizations are going to have to adopt AI to combat AI. It's the old fight fire with fire. You're not going to be able to keep up with the barrage of new potential exploits, the new dependency upgrades that are going to be driven by the new vulnerabilities that are being found every day in your dependency stack, without some kind of AI automation. And that's going to be true of your security profile as well. You're probably going to need to have some automated security assessments of these things in order to keep up. But again, nobody would literally put an engineer in a bunker for 6 months with a list of vulnerabilities and try to defend in real time and not be able to update that list. So as you start fighting fire with fire, you need to make sure that you're injecting the latest information. Otherwise, you're just accelerating a losing game.
Yeah, absolutely. And those no true words can be said, Brian. I think that's a very fair assessment there. So, hey, Brian, we talked about a lot here. There's a lot that the organizations and the audience that's watching this to take into consideration. Regardless of where the viewers are in their journey, where do why don't you provide some final work? Where can they go to get started? How can they go to understand this and take part in like what the future of coding and security looks like?
Yeah, so we publish studies like this, a big one every year called the State of the Software Supply Chain. We've done that for like 11, 12 years now. More recently, because things go so much faster, we've been doing quarterly updates. So if you go to our website, sonatype.com, and you look under the research section, you can find a lot of these things that I've been talking about, including the latest analysis of the models. That is something that we continue to evolve, but we're always trying to take a look at what's going on with the latest trends and provide guidance and feedback and tools, of course, for people to be able to deal with this on a real-time basis.
Well, Brian, I mean, thank you for your insights. This has been really an important conversation to have, especially as organizations are looking at modernizing their applications. So thanks again for joining me on today's episode. And a big thank you to all of you who've tuned in. We do appreciate you being part of the AppDevANGLE community. But for now, that wraps up this episode. And we'll be back next Wednesday with another conversation diving into the tools, trends, and talent shaping the future of application development. So whether you're deploying at the edge, building with AI, or modernizing your cloud stack, we've got you covered. Be sure to follow us on social if you have any thoughts, questions, or just want to connect. Until next time, stay curious and stay building.